Hello friends, welcome to my channel. This is Engineering Mechanics Isro question paper from 2006 to 16. Question is, the figure shows three small spheres that rotate about a vertical axis. The perpendicular distance between the axis and the center of each sphere is given. Mass of highest rotational inertia about that axis is how much? Rotational inertia I is mass into distance square. So we take 1, 2, 3, 3 masses for I1. For mass 1 it's 36 kg into distance 1 meter square is 36 kg into meter square. I2 is 9 kg into 2 square distance, it's 36 kg into meter square. I3 4 into 3 square is 9, it's 36 kg into meter square. So I1 equal to I2 equal to I3. All are having same rotational inertia. So D is our answer. Next question. A thin circular disc is rolling with a uniform linear speed along a straight path on a plane surface. Consider the following statements in this regard. Thin disc here let center is O, it's I, here P. Let center is having velocity V. 4, 1, 2, 3, 4. 4 statements are given. All points of the disc have the same velocity. No. Here at I point it's 0, O point it's average V, P point it's more than V. So A is not possible. 1 is not possible. Second, the center of the disc has 0 acceleration. O point it's not changing direction, so it's having 0 acceleration. Third, the center of disc has centrifugal acceleration. No, it's 0. The point on the disc making contact with the plane surface has 0 acceleration. At I point, it is having 0 acceleration. So, from option A, 1 and 4 are correct. No, not possible. B, 3 and 4 are correct. No. 3 alone is correct. No. D alone is correct. So D is our answer. Next question. If a number of forces act on a rigid body, each force may be replaced by an equal and parallel force acting through a fixed point together with a couple. For the rigid body to be in equilibrium, A, both resultant force and couple must be 0. B, the resultant couple on the body must be 0. C, the resultant force at the fixed point must be 0. D, none of the above need to be 0. For rigid body to be in equilibrium, both resultant force and resultant couple must be 0. A person walks up a stalled escalator in 90 seconds. When standing on the same escalator, now moving, he is carried up in 60 seconds. How much time would it take him to walk up the moving escalator? Let T1 is the time walks up a stalled escalator, 90 seconds, and T2 escalator moving, that time it's 60 seconds, and let V1 speed of person and V2 speed of escalator. And S is the distance. Distance is fixed here. So we know speed is distance by time. This one we will use here. So for case 1, distance is same. S by V1 speed of person is 90 seconds. Case 2, S by Vt is 60 seconds. So, and in T3 he asked in moving escalator how much time it will take. T3 distance is same, V1 plus V2, both will add. It's relative velocity. So from 1 and 2 we'll get V1 and V2. This is S by 90 plus S by 60. So here we'll get S by 180 2s plus 3s. So we'll get 180 s by 5s. Distance s cancel. 180 by 5 is 36 seconds. B is our answer. A stone of mass m at the end of a string of length L is whirled in a vertical circle at a constant speed. The tension in the string will be maximum when the stone is at maximum tension. Here maximum tension is our reactive force. This is our tension. In this case, when it is at top, here mg or W plus centrifugal acceleration m omega square r, both are downward. So in this case T equal to W plus m omega square r. But when it will come at bottom, centrifugal force m omega square r towards center, T, here W. In this case T equal to m omega square r minus W. So at top it's maximum. A is our answer. Two satellites of mass m and 2m are on the same circular orbit around Earth. If the velocity of lighter satellite is VO, what is the velocity of heavier satellite? Take the data. M, radius is same, velocity of lighter satellite, and second one 2m, radius same, V he asked, velocity of the heavier satellite. So rotational angular moment, m vr, mr vo is same, both case 2m r into v, r cancel, cancel, v equal to vo by 2. So A is our answer. This is rotational angular momentum or moment of linear momentum. Which of the following statements regarding laws governing the friction between dry surfaces are correct? Frictional force mu into normal reaction. 1, 2, 3, 4. 1, 2, 3, 4. 4 statements are given for dry surface, friction between dry surface. 1. The friction force is depend on the velocity of sliding. No. The friction force is directly proportional to the normal force. It's N. Frictional force is proportional to N. Correct. The friction force is depend on the material of contact surface. Force proportional to mu, coefficient of friction or material of the contact surface. The friction force is independent of area of contact. Yes. Frictional force is not depend on area of contact. So 4 also correct. 2, 3, 4 are correct. A is our answer. Next. If two bodies, one light and other heavy, have equal kinetic energies, which one has a greater moment? And let heavy body is m2 and lighter body is m1. 2 is greater than m1, having equal kinetic energy. Half m1 v1 square is half m2 v2 square. Cancel. Then multiply m1 m2 here, both side m1 m2 you multiply, so you will get m1 square plus m1 square into v1 square m2 v2 square into m1. So m1 v1 by v2 whole square is m1 by m2. m1 by v1 2 by v1 root over of m1 by m2. So we know m2 is greater than m1, so this term is less than 1. So m1 v1 is less than m2 v2. Greater momentum is having heavier body. Here m2 is greater than m. A is our answer. A heavy block of mass m is slowly placed on a conveyor belt moving with speed v. If coefficient of friction between block and the belt is mu, the block will slide on the belt through distance. Here we will use work energy principle. Conservation of energy. For that our formula is Here conservation of energy E1 equal to E2 total energy. So at position 1 and position 2, here this is potential energy at position 1, this is kinetic energy at position 1, this is spring energy at position 1, this is work done, force multiplied with distance moved. And here in second case at position 2, this is potential energy mgh, and here this is kinetic energy position 2, this is spring potential energy at position 2, this is resisting force into distance. Here we will use this formula. In this case, coefficient of friction given, so here mgh initial kinetic energy is there, no spring, cancel, fd also cancel. So finally what we got, half mv square equal to frictional force into d. We know frictional force is mu into n. N is our mass into g. So half mv square is mu m g into d. Gets cancelled, so distance d we have to calculate. It's b square by 2 mu g. b square by 2 mu g. D is our answer. A car moving with uniform acceleration covers 450 meter in 5 second interval and covers 700 meter in next 5 second interval. The acceleration of the car is how much? So uniform acceleration, first it covers s1 equal to 450 meter, t1 is 5 second. In next 5 second interval, s2 will add 700 plus 450, it's 50 meter, and t2 is 5 plus 5, total 10 second. The acceleration of the car, s equal to ut plus half at square will apply here. 450 equal to u into t is 5 plus half a into t square. 5 square is 25. Then (150)(s2) is u into time is 10 second plus half a 10 square is 100. So for better calculation, here we will multiply 2, it's 900, 10u plus 2 cancel, 25a, here it's 50a. So 1150 is 10u plus 50a, equation 1. Then equation 2, 910u plus 25a, equation 2. From equation 1 minus equation 2, you will get 250 equal to 10u cancel, it's 0, 25a. So a is 250 by 25, it's 10 meter per second square. From option D is our answer. A particle starts with a velocity 2 meter per second and moves on a straight line track with retardation 0.1 meter per second square. The time at which the particle is 15 meter from the starting point would be how much? Particle starts with velocity u is 2 meter per second moving on a straight line track with retardation. Retardation means take minus meter per second square. Distance s is 15 meter. Time you have to calculate. So first we have to calculate the final velocity. V square is equal to u square plus 2as. So v square equal to u square is 4 minus a is in negative, so 2 into 0.1 into distance is 15. It's 1 by 10. So 5 into 3, 5 into 2, 2 cancel. 4 minus 3, it's 1. So V is 1. Then we can put it as time we have to calculate. V equal to u plus 80. So 1 equal to u, 2, a negative, so 0.1 into time t. 0.1 into t is 2 minus 1, it's 1. So t is 1 by 0.1, it's 10 second. From option A is our answer. Two particles with masses in ratio 1:4 are moving with equal kinetic energy. The magnitude of their linear momentums will correspond to how much? This one also already given, already discussed in this same video. Second time this question was asked. Particle with masses m1 by m2 is 1 by 4. Kinetic energy is equal half m1 v1 square is half m2 v2 square. Half cancel. Magnitude of their linear momentum m1 v1 square, you multiply m1 divide m1, here you multiply m2 and divide m2, will get m1 v1 square by m1 m2 v2 square by m2. m1 v1 by m2 v2 square m1 by m2. So linear momentum m1 v1 by v2 is root over of m1 by m2. m1 by m2 is 1 by 4 root over it's 1 by 2. The magnitude of their linear momentums will conform to the ratio of 1 by 2. 1:2. So B is